Hola, mathletes. So we're going to talk about solving quadratics, and we're going to do this a few different ways. And today, or in this lesson, we're going to talk about doing it by graphing. Okay. All right, and there's a few different ways that we're going to actually solve quadratics. So first of all, let's talk about a quadratic equation. We talked about a quadratic function, right? So a quadratic equation is basically a quadratic function that's set to 0. Okay, so it's just basically this, but instead of f of x on one side, you'll have equals 0. All right. Okay. So the standard form of a quadratic function, I think I mentioned this the other day, but standard form is where you have it kind of like what we saw in the last lesson, right? Ax squared plus bx plus c, where you have your quadratic term, then your linear term, then your constant term, and basically they're all grouped together on one side, and the other side is either f of x or 0, and that's basically standard form. Also, a, b, and c must be integers. Okay. All right. There's other forms of quadratics too, like vertex form, and a couple. I think there's one other one that we may see later on. But those are the two main ones: vertex form and standard form. So the next word here, root. So root is the solution of a quadratic equation. So if you set a quadratic equation set to 0 and you solve for x, that's the root. Okay, and that's what we're going to be doing for a couple lessons here. Now, we're going to solve by graphing today, but we're going to learn some other ways too, like factoring. We're going to learn the quadratic formula, completing the square, and so there's different ways of doing this. But graphing is definitely, especially if you have your graphing calculator, is one of the more kind of comprehensive ways. Like, it works for all situations. And then a 0 is kind of synonymous with root for all intents and purposes, but the 0 is the x-intercept of the graph of a function. So these are basically the same thing, because even though they mean different things, even though they have different meanings in terms of like, this is actually the algebraic solution, and this is the graphical graphical version of that, but they mean the same thing. They're basically the solutions to a quadratic. So let me show you what I mean visually. Okay, so we saw this yesterday, right? And so we know how to find now the vertex, the y-intercept, and the axis of symmetry, right? We found all those yesterday. Now what we didn't find are the x-intercepts, and that's what we're going to find today. So the x-intercepts, remember that another word for that is roots. Okay, and those are basically the same as zeros. Okay, the algebraic solution is also the x-intercept. Okay, so x-intercept, 0, roots, even solutions, those are kind of all synonymous. Okay, so if I say the solution, the 0, the root, or the x-intercepts of a quadratic, I'm talking about where it crosses the x-axis, when it's set equal to 0, what x equals, and so forth and so on. Okay, now remember that this is just kind of a specific example of what a parabola looks like, right? Where our y-intercept happens to be -3, and we have x-intercepts of -1 and 3, and so forth, right? Axis of symmetry is x equals 1, right? So all those things are specific to this particular parabola, but we know that it could be facing up like it is. We could be facing down. It could be shifted over to the left or the right with some transformations. It could be stretched or compressed, different things like that, right? And so when we're looking for zeros, solutions, roots, x-intercepts, when we're looking for those values, there are different scenarios, right? And so so visually, there are a few things that could happen. We could have two solutions, which is what we see in this example here, right? Where a parabola goes down underneath the x-axis and comes back up, and so it crosses twice. Or it could go the other way around, right? Like that, and cross twice. So it could cross the x-axis twice or have two solutions. That's probably the most common situation, where you have two solutions. Or you could have one solution, and that's where it just is perched on the x-axis, right? Where it's just barely touching at one point, and that point is the vertex, right? or it could be upside down, hanging from the x-axis, right? Where the vertex is still on the x-axis, there's only one solution, but it's upside down. So there's situations where you could have one solution, and then there are situations where a parabola never touches the x-axis, right? Where it's above the x-axis facing up. If the vertex is above the x-axis and it faces up, it's no real solution. Or if you have a parabola that's below, or a vertex that's below the x-axis and it's facing down, right? That could be a situation where you get no real solution as well. All right, so those are the situations. So you could have two solutions, one solution, or no real solution. Now I want to make one distinction here. This word here, real, no real solution. So the reason that distinction is in there is because even if you have a parabola that doesn't cross the x-axis, there are no real numbers that work for that. But we're going to see later on in a couple lessons where we have complex solutions or imaginary solutions. And that's where we can still solve it algebraically, and we have some terminology and tools we can use to get these values, these imaginary or complex values. But they're not real solutions. They don't show up on a number line. They're not something we can tangibly look at or evaluate, but we can think of them conceptually. And so we're going to talk about those and why they're important later on. Okay, so for right now, we'll just say no real solution.